Hi learners, welcome to the lecture number 3 on communication models of IoT. So this is again part of this IoT design and applications course. So already we have seen two things. One is on introduction to IoT. Second is what are the different communication protocols of IoT. So now this will be communication models. So once we are having access to all these things, we can able to design any particular IoT application without any hiccups. So first model here we have is client server model. So this model we have been doing over a period of time. So most of the computing aspects have been started in the first client server communication. So the simple model here is client server model. So what you can see is we have resources here and we have a server here. The server is pulled with the resources on a bidirectional way. The client, whenever give a request to the server will respond back to the client. So this is how the way the client server model works. So client server model is a very simplest model, where we have decentralizing the server and the client resources, and the resources are in a separate tier. So this is how the way first way communication model will be working in IoT applications. Second is the publish subscribe model. So as we have seen in the publish subscribe model, most of the protocols like MQTT, DDS, data distribution service, and AMQP, most of these models we have been using publish subscribe model here. So publish subscribe means we can see that there is a broker. In between we have a broker and we have a topic 1 and topic 2. So topic 1 is subscribed by two different consumers, 1 and 2, whereas topic 2 subscribed only by one consumer, consumer number 3. Whereas a publisher can send messages to these topics. Message to be published to topic number 1 is be a separate line, and message published to topic number 2 will be a separate entity. So that means those who get published for topic number 1, they will be subscribed, and the consumer 1 and 2 will be getting those messages, and consumer 3 will be getting this message. So one good example you can think of is, let's say again a patient is wearing a smartwatch. In smartwatch there are two things: body temperature, a heartbeat of the particular person, and the environmental temperature. So that means the environmental temperature means the outside the room temperature. So suppose for example a doctor is reading to a particular data. So the doctor can get only two data from that. One is the body temperature of the human being and the heartbeat, whereas the environmentalist can able to get the room temperature of it. So that means from the same device it will be sent to two different topics. So topic 1 will be on for the doctor, topic 1, and topic 2 will be for the environmental specialist. So this kind of model we usually call it as publish and subscribe model. So in recent days in some of the cars and on some of the vehicles, this MQTT is there. So that means whenever a car is broken down on a national highway, immediately the car provider or the car service center, they can able to get the data remotely by accessing to the car's dashboard. So in the dashboard they have a MQTT broker, and that will give what is the purpose of this accident, or what is the purpose of the breakdown of the particular car. They can able to get the data. So that is one method. Another method is, once the car is given for the service, so in the service station they have a diagnostic device attached to the car, that only the car service provider can able to access that by diagnostic information. So that means once the diagnostic information has been accessed, they can able to get the data about what happened to the car. So it's something like a black box in an aircraft. Similarly, we have this MQTT architecture is available in some of the car manufacturer. So push pull model. So this kind of model we usually see that our emails in our mobile phones. So usually emails in our mobile phones, what happens, as and when the email arrives, so you can able to pull that particular from the local cache, so that you can able to read your emails. So this is the push pull model. So there are two models here: fetch model and the push pull. So push pull model means the publisher send messages to the queue. So this is a queue here. So in the queue the message will be pushed one by one to the queue. So what happens is the message pulled from the queue. When the consumer just sometime what happens is, you are opening your mobile phone after, let's say after 30 minutes of charging, you taken a mobile phone, and you can see that there are no emails. That simply what you open the email app and then simply swipe down. So once you swipe down, automatically all the messages will be pulled. So that is what happens from the queue. So from this queue all the messages will be pulled to the consumers. The same model we call it as a push pull model. So the publisher will send messages to the queue, so the queue will be having it. See, even that's what happens. Sometimes if you maintain your email address in two different devices, in one of the devices you have deleted it. So maybe within no time, if you go and check the other device, you can able to see what email have come, because it will be there in that particular queue. Still the message might be existing in the queue. So maybe after a period of time that also will be getting deleted from the queue too. So this kind of model we call it as the push-pull model. So first thing is client server, pub-sub and push-pull. Next thing is exclusive pair communication model. So this is again like similar like a client server communication but exclusive pair. So in the sense that, so for this pair for this, so it is something like a relationship between two different machines. Only those machines can able to communicate to each other. So you can see that the first message is the client is sending a request to the set up a connection. The server is response accepting the request. Message from client to server, message from server to client, connection close request and connection close response. So it is exclusive pair communication model, means only these two devices can able to access, only this client is eligible to access the server and no other things. So it is something like a corporate business partner seeing that you have a full-fledged project manager for this project. So for any queries you can contact the project manager directly. You need not contact anybody else, or you need not contact it's something like a one point of contact. The same way this client can be getting every data from this server. The server can able to handle this client only. So that is we call it as exclusive pair communication model. So there are 4 different models as we see in the client server, push pull, publish subscribe and exclusive pair communication model. Now we have IoT communication APIs. So what are the different kind of APIs? So why we need an API? See, for example, if an IoT device sends us a data, after this senses it, how it can able to push or pull to the particular server or any queue, how we can push the data, how we can able to publish it. So what kind of APIs or softwares are existing? That's what we call it as IoT communication API. So one thing is REST. So REST based APIs are very powerful because of these days. So even if you take Arduino, Raspberry Pi, you can take Node.js, you can say React.js, Angular.js. So most of the scripting languages, they are relying on these REST based APIs. So representational state transfer, that's what we call as REST, representational state transfer. So we can see that we have a HTTP client here, REST ever HTTP client, HTTP packet, get, put, post and delete method, REST payload, it is on JSON XML, HTTP server, authorization, REST full web service. So completely from the HTTP client, it sends a value to the HTTP packet is sent to the server. When the server, it just gets the resource, uniform resource indicator. So the URL and other requests, so what kind of requests have come, what kind of sensing requests have come, everything will be handled by the resources, will be sent back to the HTTP server and their request will come back to the client. So this is how the way REST based communication APIs work. So most of the web clients or even nowadays the mobile clients, they can handle using this REST APIs. So design web services and web APIs focuses on resources and how they are addressed and transferred. Okay. So in this case, let's see, for example, I am accessing a URL, I am accessing a particular device which is connected to a IP version 6 address which is mapped to a URL. So in that URL, as in there are 5 sensors, let's say a temperature sensor, an accelerometer, and a magnetometer, or a pressure sensor, or a microphone sensor. So there are, let's say there are 5 sensors are available. So in these 5 sensors, which sensor who is having access and what kind of request is coming from the HTTP client. So I may be requesting only the temperature request, or I may be giving only the request on the accelerometer data. So that means how the particular URL is being fetched and accordingly alerted to the client. So that's what this is communication APIs are doing. So client server concerns, clients not bother about the storage of the server. So the clients need not bother about the storage, the server can store any number of data. Server does not bother about the user interface of the client. So the server also not bother about you have to use this client or any client. So the client can be using any server and the clients can think that the storage can be handled by the server at any cost. It is stateless. So state lies at the client. So earlier days the statefulness lies at the server side. So nowadays because of not bothering the server much, so everything will be handled at the client side. So the state lies at the client. So the state being from one request to another request is completely lying at the client. So this is how the way we go for these kind of scripting languages, Node.js, then Angular.js, then React.js. So all these things have been handled at the though they are the server side scripting, but most of the requests handled at the client side itself. So it is cacheable. So most of the requests at the client server will be cached. So we can cache it. Layered system. So it is layer by layer. It happen. Uniform interface. So across devices, it will have a uniform interface. The code on demand. So whenever you need access the source code, it can be provided to you on demand with the help of this JSON. JavaScript object notation. So based on this JSON script, so you can able to access the code on demand. So this is one of the best communication APIs that's available for IoT. So you can see that get method, post method, put method and delete method. So list all the rescuers in the collection. You get info about a resource, create a new resource. Generally this post collection is already not used. So you can see that example.com API list all the tasks. Example.com API task, get info on task number 1. So let's say if you give task number 1, it gets only about the task number 1. Then create a new task from the data provided in the request. So you can create a new task, replace entire collection on which data provided in the request, delete all tasks. So you can delete all the tasks if you have a put request, and finally delete request. Example API task, list all tasks and delete task number 1. So that means based on this collection URI, you can able to get method, post method, put method and delete method. So using these methods, you can able to request a particular URI, uniform resource indicator, to list out all the tasks, or to delete a particular task, or to post an information to a task, and whatever. So these things the REST API can handle it. There is another communication as we have seen, WebSockets. So it is mainly used on TCP protocol. So here we have seen again this kind of API is also very powerful nowadays because of reliability, because WebSockets are very reliable because it's based on TCP protocol. So you can see here a client server request to set up WebSocket. It's given a request to the server, response to acceptance. So the data frames have been sent between the client and the server. After the data request to close the connection close, response by the server. So here what happens is, whenever a client server need to have a WebSocket, so most of this WebSocket base will be, and the socket will be closed initially. So whenever the socket needs to be opened, the client has to throw a request to the server. The server will open a socket, the further data communication happens, then finally the client again place a request to close the socket, so that the socket will be useful for some other clients. So that's how the way the client WebSocket APIs communications are being used. So usually the WebSocket is mainly based on this Java. So any Java application, they mainly prefer to use WebSockets rather than REST based APIs. So thank you for listening to this third lecture on IoT communication APIs.